Welcome to Power Mathematical Reasoning Test 22. So we're just going to be going through some of the skills required to answer some of these questions, and hopefully this gives you a general understanding or a better understanding on how to tackle these kind of questions. So let's just jump straight in. First, question number 2. What is the approximate difference between the distances along the two edges of the track, right? Now, you might be wondering, what are these two edges? Well, we have this red edge. Oops, not that one. We have this red edge. I'm going to draw it to the best of my capabilities. And this inner edge. Okay, so we have one outer and one inner edge. Then, the difference then between these distances is actually just going to be outer minus the inner. Okay? That's the general plan. But there's something we need to notice here. It's the fact that the outer straight section here, that's 50 meters, and the inner straight section is actually of the same length. So even if we do outer minus inner, right, the difference between those two these edges won't be found in these straight lines. In fact, the only difference between these tracks will be found in the circumference of the circles. Okay. Let me just repeat that. Because the inner and outer flat surfaces, right, or the distances which are 50 meters, are the same, are equal on both inner and the outer tracks. Subtracting those two won't make a difference because they're just going to cancel each other out anyway. So we need to be focusing our attention onto the circumference. So the circumference, outer circumference, minus inner circumference. Okay, that's what we're going to be focusing on. Right, now let's have a look at the outer circumference first. This is equal to now, what is the circumference of a circle? Circumference of a circle is 2 pi r. 2 pi r. Radius, this r represents the radius, which is from the center of the circle, found here. Let me just rub out everything else. Center of the circle found here to the edge of the circle, which will be found here. Now we're talking about the outer circle, remember? Now, we're actually dealing here with semicircles, right? One on the left, one on the right, but because there's two of them, I'm just going to count them as one whole circle. So the outer circumference is going to be with the radius 14 meters, not 14, sorry, 15 meters, because, let me do it on this side. Look at this side. Because this distance is 30 meters, then half of that, which is this distance here, is going to be 15 meters. Okay? So this radius here, in fact, is going to be 15. So we're going to put bracket 15 in there. Minus the inner circumference is going to be, let's have a look at the inner circumference. So it's going to be from here to here. Because remember, we're talking about this circle here, this semicircle, and this semicircle here. And count that as one circle. So half of 28 is going to be 14. So this distance is 14. Your radius is 14 in the inner circumference. So that's 2 pi 14. And that's it. That's all we calculate. We find that this is 30 pi then, minus 28 pi, which is 2 pi. And we know that pi is 3.14. So 2 times 3.14 is essentially what we're doing, which is the same thing as 6.28. Now we round this off to the nearest second decimal place. So that's 6.3 meters, which is our answer E. Now, question 3. Find the area of the track between the inner side track and the outer side track. Hopefully you have a time to read for that for yourself. Actually, what that question is asking for is the area of this section. The inside track, where the runners actually run. Okay? What is the area? Well, how do we find this? How do we tackle this? Well, as always, we're going to set up a strategy or a plan. We're going to say, well, the whole area of this section minus this red area, so the inner side. Then hopefully you see what's left is just this outer area, okay? Which is exactly what we're looking for. So let's try that. How are we going to do that? Well, let's have a look. Let's first deal with the area of the rectangles first, okay? The area of the rectangles, what do we have? Is outer minus inner still areas. So that's going to be, what's the outer area of this rectangle? It's 30 by 50. But then we also have the outer semicircles, don't we? We treat that as one circle because again there's two of them. And how do we find the area of those circles? That's pi r squared. But what is this radius? We found that earlier from the second question. Radius happened to be 15. So we write 15 squared minus. Now, this inner area, we're going to have to surround it with a bracket. What's the inner area? Let's have a look. What's the inner area? Let's deal with the rectangle inside first. It happens to be 28 by 50 as well. Plus the inside semicircles that count as one circle. It's going pi r, what's the radius? 14, as we found earlier, 14 pi r squared, like that. So now that we have that, we just calculate 1500 plus 15 squared, guys, is 225 pi. Okay, and minus, what's 28 times 50? That's actually 1400 plus, what's 14 squared? 196, and then times pi, so pi. Okay, now we do that, we get 1500 plus 225 pi minus 1400. Now remember, if there's a bracket and there's a minus in front of the bracket, we have to multiply to the same as well. So that means minus 1400 minus 196 pi, not plus, okay? Minus as well. So we do that, that's going to be 100 plus what is 22 pi, 225 pi, whoops, minus 196, well that's 29 pi. Okay, we calculate this and we actually end up getting 191.11 squared meters. Okay, and that is our answer to B. Now let's have a look at question number 8. Peter draws a picture of a cottage with a palm tree in front. His picture, the palm tree is 16 centimeters high and the house is 6.8 centimeters high. In reality, the palm tree is 20 meters high. How tall is the house in meters? Well, let's draw the situation. So Peter, on his lovely piece of paper, he draws a palm tree. Now, if you excuse my drawing, actually that's not very bad. And then I have a house, don't I? Okay, and in this drawing, he measures the palm tree to be 16 centimeters and the actual house to be 6.8. Now, in reality, he realized that for 16 centimeters, in reality, it was 20 meters high. Okay, meaning that, everyone, hopefully you follow with me, meaning that 1 centimeter, which is 16 times less, not times, 16 times less, is gonna be also 20 over 16 meters. Okay, so this is divided by 16. So because 16 centimeters is 20 meters, I can actually find out how much 1 centimeter is by dividing 16 and from 20. So 20 divided by 16, then I get how much that is in centimeters. So 1 centimeter is 20 over 16 meters. Then, the question, why did I find that out? Because the question asked, how tall is a house? And how many centimeters is the house? 6.8 centimeters. Okay, and how many times is that greater than 1 centimeter? Times 6.8. So hopefully you can see why I wanted 1 centimeter first. So I can easily times 6.8. So if 1 centimeter is 20 over 16, and then 6.8 centimeters, which is 6.8 times greater than 1 centimeter, is also going to be 20 times 6.8 over 16 meters long. Okay? And so this looks overly complicated, but in fact, it's quite simple because once you work it out, what's 20 times 168? It is 136 over 16. And that is actually equal to 8.5 meters. Okay? So the answer is B. Hopefully that makes sense. It's a lot easier once we do our ratios like this. Okay, 16 to 20. Then that means that's the same thing as saying 1 centimeter to 20 over 16. It's just easier for us. All right, question number 9. Traveling by train from Brisbane to Sydney, I passed a sign saying Sydney 320 kilometers. Okay. After 22 more kilometers, I passed another sign saying Brisbane 146 kilometers. How far is it by train from Brisbane to Sydney? Okay, so let's draw the situation up. We're at Brisbane. Okay, I know, and then we have Sydney over here. On the way from Brisbane to Sydney, right, I find a sign saying 320 kilometers. Now, a lot of students will trip up here thinking that, well, if it says Sydney is 320 kilometers away, I've already got my answer. Because how far is it by train? It is from Brisbane to Sydney, it's 320. So they'll start looking at the answers looking for the number 320, but it's not there. So that's where we get tricky. Now, that sort of idea or train of thought is actually based on the assumption that the sign was found here at the beginning of the trip. Okay? But that's not the case. We weren't told that. Okay? We weren't told that as soon as I started traveling, I saw 320. Okay? So we can't say that's how far Brisbane is from Sydney. So we cross that out. That's a wrong assumption. In fact, the sign might be somewhere here. We don't know. Sign might be somewhere here along the track. We actually don't know. But that just makes us go with the information we do know. We know that after seeing 320 kilometers, after 22 kilometers of that, right? Let's say this is 22 kilometers. After, we see a sign saying what? 146 kilometers left. Okay? Now, after 22 kilometers, 146 kilometers left from going to Brisbane. Now, this is the trick. This sign here, this sign is actually talking about this distance from here, from this point to Brisbane. It's saying, well, if you imagine you are the car going from Sydney to Brisbane and not Brisbane to Sydney like we are, then if you stopped at this point, you'll see this sign saying, oh, I've only got 146 kilometers left to Brisbane. So that shows that from this point to this point, we've got 146 kilometers. Okay? Then for the remainder, we only need to find how far this distance is, right? Well, how far is that distance? Well, let's have a look. If it was Brisbane, if it was 320 kilometers, and we traveled past, and it says 22 more kilometers, that means we saw the second sign at 22 kilometers after seeing this 320. So we must have been how much closer? 22 kilometers closer to Sydney, right? Meaning that 320 minus 22 is the way to find this yellow distance, which is 198. Okay. Oops. 198. So let me reiterate what I mean by that. Because I saw the 320 kilometer sign at some point, and 22 kilometers after that I saw the second sign, right? I'm going to say that the second sign was 198 kilometers from Sydney. That's definite. And we also know 146 is definite because it was going, there was a sign saying that. So we're actually hanging on to definite things, not the assumption here, because we don't know where this first sign was, right? So that's what I'm saying. We're holding this whole assumption based on the second sign, not the first sign, because we don't know where that is. So the answer we're looking for is 198 plus 146 because we're looking for the whole distance. And that's going to be 444 kilometers. Okay? Right. So let's look. That's question. The answer is C. Let's look at the question next. 7. A lump of lead is submerged in a rectangular tank 40 centimeters by 15 centimeters, raising the water level by 1.5 centimeters. What is the volume of the metal piece? Now, to tackle this question, guys, I hope you guys understand the fact that if we have a water tank such as this, and its dimensions are 40 by 15, we actually don't know the level of the water. Okay, level of the water was as is, but as soon as we put the lump, let me do it in another color, lump of metal, suddenly the water increased by, let's say that is 1.5 centimeters. Okay, you guys need to understand that volume in water, if we put anything in water, the water volume, the water level rises up, corresponding, so at the same time, to the object entering the water, because this object is pushing down on the water, so the water on the sides will go up. Okay, so I need to say water moved. So water moved equals to volume of object. Actually, I have to say volume of water moved is equal to volume of object, meaning that actually if I calculate the volume of water moved, which is 1.5 times how much? 40 by 15, I actually get our volume of object, which this equals to how much? 900 cubic centimeters. Hopefully that makes sense. If it doesn't, imagine yourself with the fist of the hand putting your fist into a bowl of water. As you do that, you'll notice that the sides of the water begins to rise in its level. That's because your fist is actually pushing down the water particles inside the bowl, and so the water on the sides will be pushed up the same amount your fist is taking up space in that water bowl. Okay, so that's why volume of water moved by your object is volume of the object itself. Okay, hopefully that makes sense. Right, finally we're up to our takeaway points, and these are some things I've written. Number 1, always plan or strategize before your calculations. And what do I mean? Well, if we have a look at question number 2, notice how we've planned this out by saying we're going to solve this by doing outer circumference minus inner circumference of the circle. We planned this, and whilst planning, we noticed that there's no need to actually put these calculations of the sides of 50 meters length into the equation itself, because it's a waste of time. Because 50 minus 50 is 0. So the difference isn't actually found in these distances here. It's actually found in the radiuses itself. Circumferences itself. Sorry, that's what I meant. So that's why I say always plan and strategize before calculations, because it always saves time, even though it may look like it takes time at the moment. So question number 2, don't make assumptions. And as you know, I'm going to address this question here. The assumption here was that this sign was shown at the beginning of the trip, but it wasn't. We actually don't know where the sign is placed. So with that assumption, we can't get anywhere to solve the question. So that's why I say don't make assumptions in the question. Okay, and rely on the facts that you know. Only facts that you know to be true. Okay, and finally, water moved equals to volume of water of objects submerged. And I say submerged because this is only in the context of water. Okay, volume. I should say volume of water moved. Okay, and that's referring to this question over here where we are talking about placing the lump into the tank. Right. Okay. That's it for today. Hopefully you guys understood and it helped with